Hey everyone, welcome back. It's been a little while. Sorry for the delay in getting this next video out. Hopefully you guys haven't been sitting through any classes without anything to watch as a lesson. I'll be sure to send over a few links just in case this happens again, so that at least there's something for you guys to do during your math class. But yeah, last couple of weeks have been a little bit busy with some schoolwork, some personal stuff. I came down with a cold, so it was a little bit hectic. But hopefully everything is back in order now. So I'm gonna try and get more regular with uploading again. Let me see if I can get this a little bit. Okay, perfect. Yeah, so I suppose at this point you would have already had uh, hopefully some time to get through the algebra unit. I don't imagine that you would be done that just yet. I will also get those solutions over to you guys as soon as possible. That is something I forgot to do. Yeah, sorry for the slight lack of organization with this, but hopefully we can get back into that now. And yeah, I think that's for in terms of like housekeeping stuff. As long as you guys aren't behind on, as long as you guys aren't so far ahead that you've run out of videos, um, then I think everything should be fine. Because the last video would have been your test review, which means the next thing coming up would be your algebra test, which um, that hopefully that goes well. If you guys haven't done that already. Um, but now, since we got to the end of our algebra unit in the last video, we're going to be starting our new unit this time, and this one is on linear functions, which some of you might remember from uh, last year. So this is something that if you were in a Canadian school system, maybe it's Ontario specific, but if you're in Canada for your high school math, then you would be starting linear functions in grade 9. So at the age of about 13 or 14 is when you would cover linear functions. So you guys can, look at yourselves and, if you're a little bit under 14, then this is slightly above the level that most people your age would be doing. And if you're 15 or 16 or 17, chances are you guys saw this last year anyway. So hopefully this isn't brand new for those of you that are a little bit older than 13 and 14, but for those of you that are just about 12, 13, 14 nowadays, don't stress too much if this unit gets a little bit confusing at times, because this is new stuff and this is stuff that's above your grade level if you were in a Canadian school system. So we're going to take it slow. I don't remember the exact breakdown that I had for the schedule for this unit, but I think we're going to spend an extra 3 or 4 classes on this unit just so that I don't have to rush through anything. So the lessons will still be about half an hour long, I imagine. This particular one might be a little bit shorter, but we're going to spend lots of time just taking it slow, going through some simple examples of what linear functions are, how to use them, how to graph them. That's right, we're going to start graphing in this unit, so bring a ruler for your next class if you can. For your next class onwards, that is. But yeah, so we're going to talk about lines. Linear function is just a fancy word for lines. So we're going to talk about lines and how to sort of represent them mathematically using the tools that we discussed in our algebra unit. We'll talk about how to graph them. We'll do some simple examples. I'll keep the examples relatively straightforward for your test of this unit, because it's just I want to expose you to this material, but not necessarily dig super deep into the material. If I end up teaching you guys again in the future, then maybe we can go into more detail then. But for the time being, I want to introduce you to what linear functions are, how we can use them mathematically, how we can graph them, things like that. And then we'll move on to another unit, which is going to build off this one. So this one is building off our algebra unit, and our next unit, which is going to be on quadratic functions, is going to build off of linear functions. Some of you, or most of you, might have also seen quadratic functions last year, so if you still have your notes from that, maybe just take a glance at it before we finish this unit. And if you saw linear functions last year with me, then maybe take a look at that as well, just to refamiliarize yourself with the stuff that we're doing here. But we're going to take it slow. We're going to take it from the beginning, as though we've never seen any of this stuff before, especially since this is on YouTube. It could be anybody watching this, somebody who's never seen this stuff in their life. But yeah, so let's start with the most important part of all of our drawings that we're going to be doing in this unit and the one after it. Oops, that should be an N. We're going to be talking about what's called the Cartesian plane. All right, so in this lesson, we might not end up doing a ton of math depending on how much I ramble. But the Cartesian plane is, if you've ever looked at a graph of, almost anything, if you look at a graph that has two axes, so you've got like a vertical axis like this and a horizontal axis like that, and you've got like a 0 point over here, and then you've got some tick marks going this way. You've got 1, 2, 3, 4 that way, and you've got 1, 2, 3, 4 going this way. This over here is your x-axis, and this over here is your y-axis. This is the way we would normally label the axes for a graph, but if you want, you can just draw in some arrows. We're not going to be doing anything with this graph right now. But so this over here is the y-axis. It's the vertical one. I don't really have a way for you to remember that x is horizontal and y is vertical, but if you guys have any such tricks, then feel free to let your classmates know. So the x-axis is the horizontal one down here, and the y-axis is the vertical one over there. I guess the way I really think about it is that x and z are both relatively uncommon letters in English, and so they both go together for the name of the axis. So if you remember which direction is horizontal, that's the axis that's going to be labeled with x. Other than that, I don't know if there's really a good way to try and remember which one is which. Just try and not confuse those two when you're drawing your graphs. So you might have seen graphs like this in the past. You don't have to draw what I'm about to draw, but like if you can get these labels down, that'd be great. But you might have seen graphs for almost anything that sometimes they'll have bars on them. So you might have a graph with its x and y axes, and it's got like these vertical bars. You might have done these bar graphs for some of your projects in the past. I know I did them on my report for the university when I was down there with you guys. So you might have a bar graph like this, where you've got like different quantities over here, and you've got like how many of them that you have over here. So this could be like how many I don't know, hummingbirds, parrots, and flamingos we have in the school, and then the count. So it would be like 0, 1, 2, 3, 4, 5 going up on this axis. The taller the bar, the more people there are. But there's a different type of graph that we're going to be focusing on in this unit, and it looks different from the bar graph that I just drew. So the graphs that we're going to be focusing on are, you have your axes, and then you've got some wiggly line or straight line going through that space, going through the space of the graph. So this wiggly line is supposed to represent something. So like for me in physics, you might have the time, so like the passage of time. So you've got 0 seconds, 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, and then going up here you have something else, something that changes over time. So like your speed, which in physics we represent with a v. So like over here at like your starting time, your stopwatch says 0, you're traveling at some speed, you speed up a little bit because your speed is going higher in that direction. So you speed up a little bit, you slow down a little bit, you speed up again, and then you sort of level off and you're traveling at a constant speed over there. That's my sort of physics take on it, because that's the stuff I work with all the time, and you guys are no strangers to that kind of stuff, because we talked about this in physics last year, and we talked about linear functions in math last year as well. But basically, you'll have a line on the graph that's representing some relationship between these two quantities. So we normally, like if you're just drawing some random graph, it'll be just the x-axis here and the y-axis here. but normally we'll use the two axes to represent something else. So like it could be the position that you're in. It could be like a lines of latitude across the globe. So it could be you could have your lines of latitude across the globe versus like the temperature or something, and you could graph how that changes, or you could have the time over there and the temperature over here, and you go month by month, January, February, March, April, and plot how the temperature changes from one month to the next. So basically what we get is that, like, for example, if you did the temperature and time thing, here's an example of where you could use this type of graph. Oops, that was supposed to be straight and it was not. Let's say we've got this going here, and we've got this going over here. Let's see, right now it is January 2020, and then we've got February, March, April, May, June, July 2020. So this would be February, March, April, May, June. So if you got something like this, and then you've got, so this is your time in months or whatever, and then up here you could have something like the temperature. You don't have to write just one letter. You could leave it as X and Y if you want. The physicist in me has to put a capital T for temperature and a little t for time. And then you could just, you have some numbers going up here. Normally when you look at these graphs, 0 is the one that's right on the axis. So we could put 0 right here. So this 0, really there should be two zeros. This 0 down here, given that we're writing this out in months, doesn't really make sense. But this is basically when you start your stopwatch going in that direction. This 0 point is where your time starts. And then as you move along the horizontal axis, time is passing from January to February to March to April and so on. And then going up this way would be your temperature. So 0 degrees is down here, and then you could have 5, 10, 15, 20, 25, 30, and so on, as high as you need it to go for your graph. And then, let's say that each of these tick marks is the first day of the month. So this is January 1st, this is February 1st, March 1st, and so on. Then that means that there'd be a whole bunch of little tick marks in between these two. So you have a tick mark for January 1st, January 2nd, January 3rd, all the way down to the end of January. Then you have another one for February, and then you could start from there. So if you're plotting out your temperature things, it could be as simple as every morning you wake up, you go to your phone or to a thermometer outside the house, and you check what the temperature is, and then you just mark a dot on your graph. So if it was January 1st, and let's say it was 27 degrees, for you guys, here it was like minus 27 degrees, but whatever. It's 27 degrees, you could put a dot up there for that. And then let's say January 2nd, it's a little bit colder, 24 degrees, and then 23 degrees, and so on. And over time, you'd get a whole bunch of points going along this graph. And basically what we'll do at the end of it, once we've figured out all of those points, is we'll just connect them as best we can. So that would be where your wiggly line comes into play on your graph. It's not always going to be a straight line. It's not always going to be a nice, neat curve. It won't always be like a circle or a half circle or a quarter circle. You'll just get wiggly lines that's representing a relationship between two different quantities. So in this case, we've got temperature up here and time down there. So this line is showing you how the temperature changes in Cabrera over time. Okay, so it's a little bit of a strange idea if it's something you haven't done before, and if any of you have ever looked into like scientific papers, you'll see that the graphs don't work out that way. The graphs will work out like they've got a whole bunch of dots kind of all over the place, and then they've got one line that sort of cuts through it. We're not going to be talking about those types of lines so much in this unit. Those are for entirely different purposes usually. So we'll ignore these types of graphs in this unit. We'll focus on the graphs that we're going to focus on is going to be like, you're going to have an equation. So this is the stuff that comes out of our algebra unit, okay? So you're going to have an equation I'll give you an example of how we're going to build these graphs. So let's say let's draw our Cartesian plane. We'll keep just this bit for now. We're going to expand on this idea in a sec though. So we've got zeros there. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oh, the 6 is way off to the side. That's our x-axis. And then going this way, we got 1, 2, 3, 4, 5. I guess I only got 5 that way. Okay, 1, 2, 3, 4, 5. Great. All right, so we've got our x-axis and we've got our y-axis. Great. And let's say I give you the equation y equals, let's do, I don't want to do this. Let's do y equals 1/2 of x. Okay, so you could write that as 1/2 of x, or you could write that as x divided by 2. Both of those are fine. You could, if you wanted to, you could write this as x equals 2y. That might be an easier way to do it for this particular equation. But basically what we want to do is, if I give you an equation like this and I ask you to graph it, here's how that's going to work. I'm going to keep it as, let me write it as y equals x over 2. And I'll get rid of the other ones. So we got y equals x over 2 as our equation. So basically the way this works is, the sort of general practice, the convention that people tend to use is to keep y by itself. And then the way you figure out where to put your dots on the graph comes from, basically you just plug in a number into this equation wherever you see x. So let's say you plug in x equals 1 into this equation. Alright, so let's say I'm telling you x is equal to 1, calculate y. This is similar to our questions in our algebra unit where I said, find x and y. I give you some information. In this case, here are your two equations, y equals x over 2 and x equals 1. So you could plug in, okay, well, x is 1, so I can plug that in there, and I can get a value for y. But the difference with our linear functions unit is that instead of finding just one value for x and one value for y, you can choose your x value, and then we'll just go ahead and calculate whichever y value goes with it. So, for example, let me make a little table down the side. You can copy this down if you like. So let's say we got our x values. Oh, that does not look like an x to me. We got our x values here. We got our y values there. So let's say I choose an x value of 0. All right, I want x to be equal to 0. So if this is our x-axis, x equals 0 is wherever you see the 0 on the x-axis. So that's going to be right here. But the thing is, if the y value is like 3, then at this point of x equals 0, I have to find 3 on the y-axis. So that's we're going to get to that in just a sec. So first of all, if x is equal to 0, let's plug in 0 into this equation. So we get y is equal to x over 2, but if x is equal to 0, then that means y is equal to 0 over 2, which is still 0. Okay, so when x is 0, y is equal to 0 for this particular equation. Alright, let's say x is equal to 1. Alright, when x is equal to 1, well, if I plug that into this equation up here, y is equal to x over 2, but x is equal to 1, so y is equal to 1 over 2, so that's a half. So I could write in a half over here, or you could write in 0.5 if you prefer. But so we got that when x is equal to 1, y is equal to 1/2. Alright, what about when x is equal to 2? When x is equal to 2, then up here, y is equal to, well, it was originally x over 2, but now we're saying that x is equal to 2, so y is equal to 2 over 2, which is 1. And you can sort of see, for simpler equations, you can sort of see this just by looking at the equation. This is telling us y is equal to 1/2 of x, which is why I originally wrote it as 1/2 x, like this. Because then this is 1/2 times whatever the x value is. So if I tell you x is 15, you could just find half of 15, which would be 7.5, and you could plot that on your graph. Here's how the plotting works. Let's talk about how to plot these numbers on your graph. We'll do one more, one or two more points on the graph, and then we'll plot them. So let's say x over 2 again. All right, let's say when the x value is 3. When the x value is 3, y is going to equal x over 2, but x is 3, so that'll be 3 over 2. So the y value is going to be equal to 3 over 2, which is the same thing as 1.5 if you prefer. That's also the same thing as 1.5. All right, maybe we'll put this as 1.5. So then this 1/2 up here, we can also write that as 0.5 for that value right there. That's 0.5, and then this down here is 1.5. All right, so what we've got is x is 0, y is 0, x is 1, y is 1/2, x is 2, y is 1, x is 3, y is 1.5. So the y value is always half of the x value in this particular equation. You change the equation, you change these points. Okay, so you can always choose the x value, but the y value depends on this equation up here. The way it works is, it's like you've got like a little machine, and you've got like a place where you can put in stuff and a place where stuff's going to come out. This machine is your function. All right, this machine is your function. You put in your x value over on this side, and it's going to spit out your y value for you on that side. So if you plug in a 1 over here, and then your function tells you, okay, well, y is going to be equal to whatever the x value is divided by 2. So basically, this machine, what it's doing right now in this case is I put in a number, this machine chops it in half and gives me that result. So I put in a 1, it gives me 1/2. I put in 2, it gives me 1. I put in 10, it gives me 5. Every time this function does the same thing. I choose what I want to put into this side of the machine, and then it does the same calculation to it every single time, no matter what number I put in, and it spits out the result for me. So that's what's happening over here. I'm plugging in a 1, so I'm putting a 1 into the machine. It's dividing it by 2 and spitting out a result. So we got a 1 that I put into the machine, and we got 1/2 coming out of the machine. All right, so that's how this works. You could change the function, make it y equals x plus 5, and the machine over there will, whatever number you put into it, it'll add 5 to it because it's x plus 5. And then that'll spit out your result. And then when we get the result, we can graph it. So what I'm going to do is, for now, I'll leave that up there. We'll do one more thing down here, and then I will get rid of that function so that we have some space to actually draw a graph. All right, last x value. Let's say x is equal to 4. Squeeze that in there. X is equal to 4. Then our y value is going to be 4 divided by 2, which is 2. So for this function in particular, every x value, it's just going to be divided by 2, and that's going to be the y value. So when x is 4, y is 2. When x is 2, y is 1. When x is 1, y is 1/2. And 0 divided by 2 is still 0, which is why these two are the same over here. So now let's figure out how the graphing works. Okay, so we'll start with 0, 0, this point right here. Mathematically, you would write these out. There's like a notation to write these out. So you would write that first one as 0, comma, 0 with round brackets around it. So the first one here is your x coordinate, your x value. Your second number is your y value. So you could have 0, 0, or maybe just so that I can highlight the difference in which value goes where. When the x value is 2, the y value is 1. So I could write this as 2, 1. That's sort of the notation that we use. All right, so it means the same thing as this table. It's just a little bit more organized. So 2 and 1, or 4 and 2. You could have 3 and 1.5, or 3 and 3/2, whatever, however you want to write it. It's just, this is the notation for x number goes first, comma, then your y value, and round brackets around it. Okay, so now we've got a set of some numbers, so let's plot them on the graph. So we're going to start by looking at the x value. So here we're looking for x equals 0. So we're looking along the x-axis for a point that has, for the label 0. So along the x-axis, the label for 0 shows up right here, right above this 0. This is the 0 for the x-axis, right? Now, for the y value, we need to, once we've located that point on the x-axis, we need to move up or down on the y-axis to find the second value. So in this case, the y value is also 0, so we don't have to move up or down at all because the y value for 0 is right here on the axis. So we plot our point. That's where our point goes. This is our point 0, 0, right here. I don't really have space to mark it in, but I'll put in 0, 0. Right there. That's our 0, 0 point. That's this first one. Done. Okay, second one, x value of 1, y value of a half. So first thing we do is we look along the x-axis. We find our x value of 1, which is right here. So somewhere, don't draw that circle. So somewhere above or below this point, or exactly at this point, we'll figure it out in a sec, somewhere above, below, or in line with this point is going to be where our actual dot on the graph goes. Because this is our x value of 1, now we need to go up or down along the y direction, the vertical direction, to find a value of y equals 1/2. Well, here, along this line, y is equal to 0, but up here, y is equal to 1. So y equals a half is going to be right here in the middle, right? Y equals a half is going to be right there. So we just move this over, we move that one up, we basically join the two together. We're moving from this line right here is in line with y equals 1/2. This one right here is in line with x equals 1, and we just make them meet up right here. And that's where we put our point. Okay, it's a little bit small, and we're dealing with some weird numbers and some fractions. Maybe this wasn't the best example to start with, but hopefully this is making a little bit of sense. We're going to plot the rest of these points now, and we'll see how this turns out. So that's our second point. We'll mark it in as that's our point 1 1/2. Okay, maybe I'll make this 0.5. 1, 0.5. Cool. Okay, next one is x equals 2, y equals 1. So going from here, we're looking along the x-axis for a value of x equals 2. So we're looking along the x-axis for 2. We found it. It's right here. And now we need to find a y value of 1. So we look along the y-axis for a value of 1. Oh, well, we found it right here. Y is equal to 1 right there. And we just need to connect these two by moving vertically from this point and horizontally from this point, and wherever they meet up, that's where your point goes. Right there. Something like that. Alright, so there's two ways you can do it. One is you find the value on the x-axis, you find the y value over here on the y-axis, and then you draw these lines in and come to a point right there. Or you could find the value on the x-axis and then directly from there move up or down. The reason I'm not doing it that way is because I don't have graph paper for the whiteboard. If you had graph paper, then you'd have these little lines sort of cutting through the whole grid, and then it's a lot easier to see, oh, well, if I didn't already draw in that dot, here's x equals 2, now I need to find y equals 1, you just need to follow the grid lines and you'll eventually hit this point right here. Alright, so because I don't have those grid lines and I can't draw very straight grid lines, like this over here is just a mess, that's why I'm doing it the other way, where I find a value on this axis, I find a value on that axis, and then I sort of join them together, I sort of eyeball it and join them together like that. Alright, hopefully that's not too big of an issue. Let's do the next one. So we've got x equals 3, y equals 1.5. So if I leave those grid lines there, x equals 3 is over here, right? We got along our x-axis. You don't have to draw in these little circles. I'm drawing in the circles right now just so that you can see what points we're talking about and things like that. But ordinarily on a graph, you don't have to draw in these little unfilled in circles and the dotted lines. All you need to do is put in the black dots here, like the filled in dots, and if you can, label them. Label as many of them as possible. So I'll put in 2, 1 for this one right here. Is at 2, 1. Alright, so now we're talking about x equals 3, y equals 1.5. Well, y equals 1 would be along this line, y equals 2 would be along that line, so y equals 1.5 is going to be somewhere in the middle, somewhere about there. And the other way you could do it is to look along the y-axis. Here's y equals 1, here's y equals 2, So y equals 1.5 is going to be somewhere in the middle, and you just come over and you bring this one up, and wherever they cross paths, that's where your point goes. So yeah, I can't make that straight for the life of me. Yeah, whatever. So there's our next point. This is 3. I'm going to have to get rid of the grid line. This is 3, 1.5, right in there. Okay? And we'll plot our last point. And hopefully you're seeing a little bit of a pattern with the black dots, that they're making a nice, neat, straight line. So let's put in the last dot, because this one's not too hard. We're not dealing with fractions or anything. So we start with x equals 4. So going along this, we've got an x value of 4 right here. We've got a y value of 2. That's the one we're looking for, right? We've got a y value of 2 right up here. So if I join those together, I bring this one over to here, bring this one over to about there, I bring this one up, and where they cross paths, that's where my dot goes. Another way you could have done it is from this 4, just go up 2 units if you have the grid lines there. If you're not using graph paper, because I kind of caught you by surprise with that, if you're using lined paper, you should still at least have these lines for the y-axis. It's really useful to use them for that. So when you're drawing in your axes and you're putting in these tick marks, line them up with the lines of the line paper. But then you can plot in your points really easily once you've either made the grid lines yourself, or just get familiar with how this sort of process works. So right, you could find a point along this axis, a point along that axis, and then just make them meet. Or you could find a point on one axis and then just travel up and down from there. Alright, hopefully that makes sense. I will label this point. This is the point 4, 2. Right, 4 is our x value, 2 is our y value, close bracket, and those are all the points that we have right now. Obviously, we could keep going. We could put in 5 or 6 or 10. Our graph is certainly big enough that we could put in another one for 5 and 2.5, or 6 and 3. But we'll leave it at the 5 dots that we've got right now. And then your last step, I'm going to see if I can do this without horribly butchering it. Your last step, once you've plotted enough points, is just connect the dots with them. Connect them in as straight a line as you can. I don't have a ruler on me right now, and then this can extend all the way over to the edge of the graph over there, and there you go. You have your graph for the equation y equals x over 2. We're going to end up talking a little bit later about sort of the anatomy of this equation and what it means and how you can draw the graph without having to go point by point by point. When we're talking later on, maybe in our next unit with quadratics, we're going to be dealing with drawing some graphs where the lines aren't all straight. And the only difference there is that if you have like a dot here, and a dot here, you still connect the dots, but instead of making it straight lines, you make it a little bit of a curved line. So you try to keep it kind of like a smooth curve instead of just making it like a mountain peak. But it's the same idea. You could have the dots going kind of like this, and you just try to keep it like a smooth curve like that. So that's all there is to it. Once you've figured out how to get the dots onto it, it's just a matter of connect the dots and trying to keep it kind of smooth. This unit, since you know that in this unit we're only talking about lines, if you're trying to construct one of your graphs and you're getting a line here, or you're getting a dot here, 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 chances are you've made a miscalculation when you put a dot up there, because you can visibly see, you can visually tell that it's not lining up, right? So that's the advantage to these graphing questions, is you can visually tell if you're doing it right, because you know that your line is supposed to be a line, it's supposed to be straight. So if your graph's not coming out straight, double check your math, double check your calculations. Obviously this is entirely new stuff, so we're going to take this unit kind of slow. Hopefully this example wasn't too complicated. The downside with these examples is that with the time it takes to build the graph and to get all these points over here, each example is going to take longer, but that's why I want there to be more lessons in this unit, so that we still do the same number of examples, but we don't have to rush through them. So if you guys have any questions, please let me know. I'm going to try and get back into a more regular schedule for when to record and upload and stuff. Yeah, hopefully you guys aren't sitting in your math class with absolutely nothing to do. Yeah, I think that's everything for this one, so I will see you guys in the next video. Have a good one.